Hello and welcome to the presentation about our results of the TimeScan application within the OGC Earth Observation Applications pilot. I'm Jonas Eberle and I work as a data scientist and OGC interfaces and data management expert at the Earth Observation Center of the DLR, the German Aerospace Center. Together with colleagues from the Land Surface Dynamics department, we explored the possibility to deploy an interoperable application package to different Earth observation cloud platforms within this pilot. Therefore, we have made use of the TimeScan processing framework that utilizes a novel approach to exploit large multi-temporal satellite time series for a variety of applications like urban monitoring and land cover classification. In this example, you see on the top temporal statistics of Sentinel-1 and Landsat for a specific time frame, and this is being used to generate a settlement and non-settlement classification map. Within this pilot, our goal was to adapt parts of this processor which has already been implemented in different environments, such as Hadoop, Docker, or Google Earth Engine, to an application package that is deployable and executable in multiple cloud platforms based on an EMS and others infrastructure which has been introduced in previous OGC testbeds. Within this pilot, we tested the deployment of our application package in 3 different platforms: Spacebell, TerraDur, and EoxHub. The workflow of the TimeScan processing framework consists of 3 steps, which you can see on the bottom of the slides. To simplify the workflow and the dependencies on external data within this pilot, we integrated the first 2 steps, data to time series and time series to stats, into 2 application packages. The first, data to time series, is a scene-based processing step to calculate different indices such as the normalized difference vegetation index. The time series to stats calculates afterwards the temporal aggregation from a whole time series of indice data. This is then later on used to produce the world settlement footprint as shown before to generate this settlement non-settlement classification map. Several considerations have been made in the process of defining the application packages and to fulfill the requirements of the platform providers. First of all, we had to define how to declare inputs and outputs of the application package. As you can imagine, data can be provided with different services as well as in different data formats and data structures. Thus, the assumption of our application package is currently that the input data is available as a local folder or file path. Also, output data of the application package need to be declared and described with metadata, which brings us to the second point, the format of the metadata. Currently, we make use of the OGC Earth Observation metadata profile of observations and measurements, which is supported by all of the platform providers within this pilot. At the beginning of the pilot, TerraDur provided a description of different processing design patterns which need to be reflected by each application package. This allows distinguishing between different handling of input data. So the fan-out pattern for scene-based processing can be automatically be executed in parallel as an example. The fan-in pattern can be used for temporal aggregation in our case. To build an application package, 2 components are necessary: a Docker container with all software-related dependencies, which includes a script which is executed, and a description of the process with the common workflow language specification. This CWL describes the executable, inputs, outputs, as well as the environment of the process, in our case, a Docker container. A CWL can be tested locally with the CWL runner tool. Only a YAML file is needed to describe the inputs of the process as described in the CWL file. But also the CWL can be deployed on remote platforms. Here you see screenshots from Spacebell and TerraDuer. But of course, there are remaining challenges. There need to be a common agreement on the CWL base class, whether this is a command line tool or a workflow. Although the concept of the CWL is the same for each platform provider, there are some differences in the CWL file regarding the base class. In addition, further discussions are not necessary when platforms provide the data with different data services and data structures. For example, if data is provided only as S3 or OGC Web Coverage Service, either the application or the platform need to handle this. Also, if multiple output files are provided in an application package, it is not yet clear how to handle the metadata for each file. Also, there may be metadata values which are platform dependent, such as the name of the processing platform. From our point of view, this needs to be further discussed in combination with the input data handling. But nevertheless, we get our application packages running on all platforms with only a few adjustments necessary for the CWL file, which is from our point of view a great step further in the direction of an interoperable application package. Thank you for your attention.